Okay, so today we're going to be talking about how to record response time and generating random numbers in MATLAB. So the first thing we're going to talk about is taking the response time. So how do we measure when something happens and the difference between one event and another event? So in some experiments that you might be doing in science or psychology specifically, you need to collect the response time or the time it takes for a participant to answer a particular question. So you give them a particular question, you record the time at which that question was given, and you record to find out how long it takes the subject to actually write or react to that question. It could be a question, it could be something written, it also could be a visual stimulus that you put on the screen with a graph or something like that. So MATLAB provides a pair of commands for you to measure that response time, and they're called tick and tock. Tick and tock, the two sounds of a clock. So the way that you use it is you initialize the timing process by simply typing in the letters tick, hitting enter, and then MATLAB will engage the built-in timer in your computer. And then you have a bunch of commands, whatever those commands are, inputs, outputs, prints, etc. And then when you are done and you want to record the end of that time, you type in the command tock, and you can also assign it a variable name. Okay, and so the tick command starts a clock. Okay, that's important, or reads the clock in your computer, and the tock command stops the clock or reads the computer's time and gives the time difference. Okay, and that's important. So we know what the difference in time is between here and there. The time difference is how much time the commands took between the tick and tock commands when they were executed in MATLAB. So here's an example of that. So we start off, we initialize some numbers, and we're going to do some multiplication and for loop. So we're going to say tick. Then we have our for loop, and that for loop takes a certain amount of time. In this particular case, it's going to loop around 50,000 times, which sounds like a lot, but it's not really. So it's going to go through that amount of time. We make sure that if we're going to do this sort of loop, we put a semicolon at the end of that particular calculation. And then when the for loop is done, then we type in 4 times, so the time it took for 4, and this could be any variable you want, that's equal to tock. Then we have an fprintf statement, or an sprintf, or a display, depends on what you want to do. And we say time taken for the for loop is %f, so it's a floating point number in terms of seconds, and then a new line, and we're going to print out the time that was returned when tock was executed. So here we go. Here's another way of doing it. Multiplying using element by element operations. We go tick to begin. So we're going to begin with tick. We're going to do some element by element operations, and then we take a look and we say we want the amount of time it took for that to happen, and we say vec time, so just another variable that we wanted, is equal to tock, and so we can figure out how much time it took to get from here to there. And then we print that value out, and we say time taken with element by element operations is %f. And you really should try this out and see what is the difference between the amount of time it takes to do this and the amount of time it takes to do that. Here's another example. We want to measure the response time of a person. So we're interacting with a person. So here is the tick command right here. That's the first line. Then we have an input command, and we're asking the person what their favorite color is. It's going to be a string. We output the result to a variable called fcolor, and then we say we want the difference in time to be stored in RT. Then we say fprintf, your favorite color is, and we give that color, and your response time is, and we give it in terms of a floating point number in terms of seconds. Here's some more examples right here. So here is one block of code. We start with a tick, we end here with a tock, and we report some value here. Same deal here, a tick, and then a tock. And we're asking what their favorite sport is, and we print the result and their response time. And one more example right here. What is your favorite number? And we do a tick and a tock. And we then say your favorite number is such and such, and your response time is this. All right, so that was Tic and Talk, measuring response time of a person or of some portion of code in your program. Generating random numbers. So this is the next thing we're going to talk about. And this is often a really important thing to do because you often want to create arbitrary numbers or simulated responses from people. And there are other reasons for having random numbers. So experiments or simulations often require using random numbers, and there's all sorts of possible reasons. MATLAB provides built-in functions for generating random numbers, including rand, randn, and randperm. So generating uniformly distributed random numbers, and all the way to generates a random permutation of a list of numbers. So you just want more, or you want more than one number. You can get a list of numbers all randomly generated. Okay, so to generate uniformly distributed numbers, here are a couple of examples. So you have rand. And so if I want to generate a single random number between 0 and 1, just type the command rand like this, and it'll give you some number. Type it in a bunch of times, you'll get different numbers every time. And remember, the value is going to be somewhere between 0 and 1, so a floating point number. After that, rand 1 comma n, and this generates a row vector of n random numbers, so a number of random numbers between 0 and 1. So I say rand 1 comma 3, and here we go. I got 1, 2, 3 different random numbers. Rand n generates an n by n matrix, so we're talking about a two-dimensional array of random numbers between 0 and 1. So if I do rand 3, I will get 9 numbers arranged in a matrix like that. And we can have a non-square matrix if we specify both the number of rows and the number of columns. So in this case, I have 2 rows and 3 columns, and I get a matrix of random numbers between 0 and 1. Again, between 0 and 1. Always between 0 and 1 in these cases here. And in total of 6 random numbers. So we can get lots of random numbers, and they will be randomly distributed. All right, the rand function can be used to generate numbers beyond the range 0 to 1. So 0 to 1 is great, but there's all sorts of reasons why you would want something other than a number between 0 and 1. To generate a number in the range a through b, use b minus a multiplied by rand plus a. So here's an example right here. N is equal to 10 minus 5. So these are the boundaries here. So 5 and 10 right there. And I do multiplication by rand, and then I add 5. And this will give me one particular number, in this particular case 8.6893, but if you run it again, you will get a different random number. So try this many times and see what happens. Next example, generate a vector of 6 numbers. So not just one number, but 6 numbers, and you want a vector of them between -5 and +5. So this is like the range of numbers that you want to have between. So m is equal to 5 plus 5. Why 5 plus 5? Because we have 5 below 0 and 5 above 0. So it's a span of 10 numbers, right? Or 10, a value of 10 in terms of integers, really. Multiplied by rand 1 comma 6. So we're going to get 6 different random numbers, and we need to give it this bias right here, -5. So m is equal to -2.3. Now that's good. -0.8. That all looks within the boundaries. 4.8. Yep, that looks good. 0.4787. Of course, that looks good too. So basically what you've got is the potential for generating numbers, in this particular case, both positive and negative, between 2 boundaries that you define. Okay, so that's great if you want floating point numbers, but let's imagine that you want a whole number or an integer. So no points to the, or no numbers to the right of your decimal point. So you can use the rand function again, but you combine it with rounding. So here we are combining different functions for MATLAB. And here's an example. Generate a random integer, okay, so a whole number or an integer, between 1 and 100. So we say x is equal to round, and there's your parenthesis there. You going to close the parenthesis there, and you insert what we talked about in the previous slide, your range, 100 minus 1, so that gives you your range, and multiplied by rand plus 1, so a little bias offset right there. And you do this once, you get a whole number or an integer, 67. Run it again. Okay, so try it again and see what happens. Do you get other numbers? You probably should. Here, example number 2. Generate a vector of 8 integers between 1 and 100. So we want a vector of 8 integers. So y is equal to round, like that. I have my range set up right there. I have my vector set up right here. So we're going to have definitely 8 different values right in there. I give my bias right there. And look at this. I have a vector of numbers 16, 2, 55, 86, 18, 45. Lots of different numbers here. And they are all between 0 and 1. And they are all whole numbers. Fabulous. Okay, next up, an exercise. Write a MATLAB program that randomly generates an addition question that asks the user to add 2 integers between 0 and 9. Then it takes the user's answer and tells the user if it is correct and measures and outputs the user's response time. All right, so we're combining different things here. All right, so here's a solution. We can generate 2 random integers between 0 and 9. So we have n1 is equal to round 9 minus 0 multiplied by random, and same thing with n2. So we have 2 random numbers between 0 and 9. Show the question to the user. So we're going to print what is some random number plus some random number, and that's going to be printed to the screen. Then we say tick, so we're starting to measure time. And now we ask the user for their answer. So we've started the countdown, or not the countdown, but the timing, the stopwatch. And the user is going to type something in, hit enter, and as soon as the user does that, we will get the difference in time between tick and tock, like that. Then check and output whether the user's answer is correct. So we do this. So was it correct? Hopefully. And then we say your response time is such and such. Okay, where RT came from up there. All right. Extend the program for exercise 1 to generate and ask the user 10 addition questions of the same kind. Tell the user whether their answer to each question is correct or incorrect, output the number of questions answered correctly, and output the average response time that the user uses over those 10 questions. Here we go. All right. So we have a for loop right there because we're going to have to ask 10 times. So we have that for loop right there. We generate each time a new random pair of numbers. Okay, so we have our numbers right here. Then we print to the screen. We ask the user what is the addition of those 2 numbers, and we start the timer. The user is then asked what is the response. The user types in that response. As soon as the user types in enter, then we get a talk, and so we know how much time is recorded by MATLAB at that point. And then we do a quick verification to see if the user's answer is correct or if it is incorrect. And then once all 10, okay, this is done 10 times. When all of those are done, then we say we do an addition of the number of correct answers is, and why is that the case? Because we have a running sum right here of the number of correct answers. That is stored in NC, and then so that's the number of total correct answers, and then the average response time is, and look at this, we have a percent point to F, so we're going to have a 2 decimal points and on the seconds, and then we are doing a calculation on all of the values inside of RT. Why are we having multiple values of RT? Because there is an index right here of K associated with RT that came from the for loop right there. Okay, and that all plays into being able to calculate the mean right there. All right, the next thing that we need to talk about is something called randn. And randn generates normally distributed random numbers, which is effectively this bell curve business, okay, where this is the average right here. And then you have very few at the top, very few at the bottom, and the majority of the population of numbers right here in the middle, which is approximately in the middle, 68%. And there you go. So the rand function, or randn function, allows you to generate a random scalar drawn from the standard normal distribution. So it's a slightly different version of the random function. And it allows you to tap into the statistical distribution of numbers based on one type of distribution model, not anything but nothing else other than the standard normally distributed function. Okay, so you can use it in a very similar way to the random function, and so you can generate a matrix, whether it's a square matrix or a rectangular matrix. You can generate a row vector as well, so you can have one number, or you can have multiple numbers as well, and they all look effectively very similar to what you would see with the standard random number function, except that the distribution of these numbers fits the normal distribution model. Okay, so here this can be really interesting because you can tap into this for determining mean and standard deviations. Okay, so the randn function, the mean and standard deviation of the numbers can be changed by using math operations to have any values. To generate a function of k numbers with mean m and standard deviation s. So you can really specify something really interesting here. You do standard deviation s multiplied by randn 1, comma k, where k is the number of numbers that you want to generate randomly, and then you put your average value m right there. So the structure is similar to what we were doing earlier. So here's an example. Generate a vector of 7 numbers with a mean of 20, so an average value of 20, and a standard deviation of 5. So this tells us what the spread of the numbers is going to be. So standard deviation tells us basically what the spread is. Very similar to the variance. So v is equal to 5 multiplied by randn, and we say that we want 7 numbers, and we want the average right here to be 20. So we want a standard deviation of 5, an average of 20, and we want 7 different numbers. And right here is the vector that outputs that. And if we wanted to, we could take a look at these same numbers, but from an integer perspective. So right here what we have is the calculation of rounding on the vector v, and so we get a vector of integer values. Beyond that, we have a function called randperm. So the randperm function generates a random permutation of a specified number of items. So similar to the previous functions, a little bit different. So randperm m generates a row vector with n elements in it. So if we said 6, then we would have a row vector with 6 elements in it, that are random permutation of integers 1 through n. So we have 6 values, and we can only get a maximum value of 1, and in this case a maximum value of 6 and a minimum value of 1, and all of the whole numbers will be shown in here. So example, arrange 10 objects in a random order. So randperm 10, and we say that we want the 10th object first, the 8th object second, the 7th object third, and away you go until the last object right here is the originally 6th object in our list. Okay, so here's an example. Write a MATLAB program that randomly assigns 10 participants to 2 treatment groups. Okay, so you can see why this would be important. So you're doing a study, a psych study on a number of participants, and you have to randomize which subjects are going where and how they're going to be evaluated or what they're going to be tested with. And this is one way of doing it very objectively, which is always important in science. So the participants' IDs are 1, 2, all the way through 10, and we say P is equal to randperm 10. So we're going to come up with this group of 10 different IDs basically, and we're going to arrange them in a particular order or in a random order, and we're going to say that we want the first group to be the 1st through 5th elements, and the second group to be the 6th through 10th elements of that new randomly associated vector. So then we say disp or display participants assigned to the first group, and we have that. And then we say what the second group is, and then we can have a research assistant or you sort of take those individuals and group them off as was assigned objectively by MATLAB. And there you have it. That was the last slide for response time and random functions.